In this figure, we want to look at renal clearance and how it is a measure of the effectiveness of excretion of particular solutes. At our upper right here, we have our schematic of a nephron and it's supplying blood flow. And if you recall, we have about 625 milliliters of plasma flow coming to all nephrons in total. We have it showing going into one here, but we're being schematic, right? So imagine this being the plasma flow to all nephrons. At those nephrons, filtration occurs at a rate of about 20% of this 625 mil inflow. So that means that we're filtering at about 125 milliliters per minute total between the two kidneys. Well, the difference, what we're missing here, is what was unfiltered. So 500 milliliters of our plasma that came in here remained unfiltered. And remember, we filter essentially plasma minus the proteins in it. And so our filtrate looks very much like plasma, except it doesn't have the plasma proteins, and it certainly doesn't have the cellular components that we've left out entirely here. Now, our urine flow is only about 1 milliliter per minute. Well, that's our excretion. Remember, that's not clearance. And so that means that we are massively reabsorbing this volume of filtrate, right? Well over 99% of our filtrate gets reabsorbed. Now, what we want to examine is the substances in this filtrate. How are they being handled by the nephron? Are they being actively excreted? Or are they being actively saved and put back into the bloodstream? And our clearance tells us entirely about this particular measure. Now, clearance would be the fraction of this plasma flow cleared of a particular substance per unit time. Cleared meaning it's had that substance removed from it. So in other words, if our clearance was 625 mils per minute, that means we're effectively clearing entirety of that plasma flow of a particular substance. That's actually true for a substance called PAH. PAH, when added to the bloodstream, gets cleared by the kidney in a single pass through those kidneys because we are actively filtering it and we're going to excrete the 125 mils per minute that's filtered, but we're also going to entirely secrete the other 500 mils per minute worth of PAH. In other words, we're going to be adding it to the nephron, leaving none in the venous outflow. Okay, so the clearance of PAH effectively tells us what our renal plasma flow is, this 625 mils per minute. Another benchmark is this filtration rate of 125 mils per minute, right? If we have a substance like inulin or similarly creatinine as a waste product we produce, is very close to just filtered alone. If we're going to clear only what is filtered, then the clearance is 125 mils per minute. And again, that's what we're showing on our line graph down here is the clearance of these solutes. Now imagine a solute that's between the clearance of inulin or creatinine and PAH. Well, that means, like solute X here that we're pointing out, that means we are adding to what was filtered. We're enhancing the excretion. We're clearing a greater volume of plasma of this substance than what was filtered. Remember, filtered alone would be GFR. If we're going to clear more than what was filtered, we are secreting. We're adding to it. And the farther we get towards 625 mils per minute being cleared, the greater the degree of secretion becomes. Just similarly, on the other side of 125, if we are clearing less than what was filtered, that means we're reabsorbing, right? And so we're going to see all of our electrolytes down here. We're going to see all of our nutrients down here. Nutrients actually give us a clearance of 0, or hopefully 0, right? That is another benchmark. We want to remove no nutrients from the bloodstream. Meaning, even though we're going to filter 20% of them, we want to clear none of that 125 mils per minute. And we're certainly not going to secrete them from the other 500 that were not filtered. And so our clearance will be 0 because we're not going to clear any nutrients from the 500, and we're also not going to clear any of what was filtered, the 125, because we're going to actively reabsorb them, put them back into the bloodstream.